Okay, we're going to keep doing the Unit 2 review. This is page 21, number 6. It's a contingency table, and I already found the totals. So if you haven't done that yet, go ahead and pause the video and make sure my totals match yours. If this was the exam, there would already be totals on the page. So this says, what is the probability that they are a smoker? So I want to remind you that if we don't see the phrase or the word, let's say, given, the denominator is actually going to be everyone. Okay, so we only change the denominator from 1,000, we'll shrink it if they say something like given. So something, this I know, I see the word given, okay? So this says, what is the probability they are a smoker? So that means in this example, let's say like S stands for smoker, okay? So that's all the people who smoked, which is 200 out of all the people surveyed, which is 1,000. And then you could reduce that to 0.2. Part B says, what is the probability they died from lung cancer? So this, really morbid, says lung cancer. Okay, and we're looking for everyone who died from lung cancer. And so we go to the bottom of where that total column of people who died from lung cancer is, and that's 130 out of 1,000, or, oh, my answer is wrong on my packet. Wonderful. Okay, I'm using my packet as my solutions, and I just realized that my answer here is wrong for this. I have 870, but 870 is the people who did not die from a lung cancer death. So I'm going to try to make sure I fix this before you guys have to go and take a look at it. When it says, what is the probability they were a smoker or died from lung cancer? So we have a formula for that. Smoker or lung cancer was the probability they smoked plus the probability they died from lung cancer minus the probability they were a smoker and they died from lung cancer. So here we go with the total number of people who smoked, that's 200. We add in the number of people who died from lung cancer, that's 130. And then we subtract the people we just counted twice, which I hope that if you go ahead and scan that row and column, you'll see that there were 50 people who were smokers and died lung cancer deaths. That's the intersection of that row and column, which leaves 280 over 1,000, or 0.28. Okay, let's keep going. What is the probability they were a smoker and, so the word and is very different from or. Or means adding, okay? In this case, and is just the intersection. Equals and in a contingency table. So in this case, we want to know the intersection of the smoking row and the lung cancer death column, which was the 50 out of 1,000 that we had just seen, or if we reduce that, that becomes 0.05. So then we keep working. We've got, what is the probability they were a smoker given they died a lung cancer death? So probability they were a smoker given they died from lung cancer. If we use our formula, that means that the numerator here needs to be they were a smoker and died from lung cancer. And the denominator is the event that was the given statement, or the thing that quote-unquote came first. And in this case, that was given they actually died from lung cancer. So, again, super morbid problem, right? But the total number of people who died from lung cancer is my denominator. That's 130. And the numerator are those smokers who also died from lung cancer, which are the 50 people we just identified in the previous problem. And if you put this in your calculator, it reduces to 0.38. And then we get the classic, are smoking and lung cancer deaths independent? Explain how you know using probability formulas. So I'm assuming you just watched my video for example number 5, which also has an independence question, which means I'm going to you assume that we remember that two events are independent if we can show that the probability of A given B is equal to the probability of A. So we always want to show, and I take one given statement that I've already seen before. In this case, smoker given lung cancer death. If we equate smoking to event A and lung cancer death to event B, then we have to show that this is equal to the probability that someone was just a smoker. Now, we have the probability that someone was a smoker was part A. So on this side, this is 0.2. And remember, this is like a question, right? We're asking ourselves if these two things are equal. This is part A, was 0.2, the probability they are a smoker. And we found smoker given lung cancer death, that was part E, and that was 0.38. So these numbers are not the same, and these events are therefore not independent. Okay, so if I do not have the same value on either side of the equals sign, then we can determine that lung cancer deaths and smoking are not independent. In other words, they are related, which is what we would have assumed if we were looking at this outside of the context of this class, I hope. All right, keep watching those videos.